The last piece of the lab is to take the system and put it into CPU set configurations and to do the same sort of problems of high system time, I/O in one CPU set, memory in the other, and present a job mix through a batch interface that's going to partition the system into a CPU set per workload. This is something we were doing just before break this morning on our systems using CPU map to figure out how I'm going to break up my system. My system has 4 blades, 8 sockets. I'm going to take one socket for a boot CPU set, which should be everything that's fired up from init, including MindGetty and the serial console, and any init.d type of service. I'm going to take the second socket and make it a login CPU set. Anything that's started up from SSHD will be in the login CPU set. Now, there is danger in this. I'm now breaking up the system into smaller pieces, making that piece easier to abuse. So if I'm only taking one socket as a login CPU set and I can fill up that socket with dirty memory or shemem memory, and then that CPU set becomes unusable. Also in the process, I'm going to take a program and looking at affinity information. So I want to take a program that I got that will come in at 9 seconds and, number one, make sure it's all on the same socket with dlook. And there's a script that I have that I advise you to get a copy of called dlook summary that will tell me what nodes my pages are on, how many pages are on each node. Again, key to the performance is to stay on node, on socket, and do not have to go across the quick path to the other socket or across Numalink to other blades and other sockets. Try to stay on socket with everything. Now I'm going to probably skip over task set, but use that to get my affinity mask. But the key thing is I'm going to take this program and NumaCTL, put the CPU and the memory on the same socket, and then put the CPU on one socket and its memory across the architecture on a different socket. I also need to start looking at the system on a per node basis. So things like SAR at this point and even PM chart don't tell me what's happening within the CPU sets. Node info will at least tell me what's happening on the memory side of things. I have at sites taken the PMGsys command and saved the -V output that we did yesterday, and then set it up for just the boot and just the login CPU set and not display what's going on with the other batch PBS CPU sets. Try to make it a little bit more simplistic. So on a large system like you got, I think you said 250-some sockets, it is hard to look at all those sockets together. This is where MPViz can come in handy. And again, PMGsys should also be in this slide. PMGsys will show me the system on a per CPU basis. Probably the easiest one to see your whole system with. Even top and PS become unusable on a large system. Just PS with all those kernel threads, one per CPU, is going to create a lot of process table entries for you. Top itself, you're not going to be able to get 256, or if you're in the 2048 to 4096 CPU system, you're not going to be able to get that many lines of top status in top. So then you've got to start looking at the system in a different way. Now I want to show you a script that you might want to grab a copy of. CPU set-Q is a script I wrote to kind of do a PS and a task set and a dlook on a per CPU set basis. And let me get to demonstrating that. It's going to run a PS-L on every thread in a CPU set, run task sets on every CPU in the set, and also a dlook summary. This will tell me what CPU I'm running on, the CPU I have affinity to, and what memory I have affinity to, and also where my pages are for that particular process. The thing I need to do right away with my new system, on Floyd 3, I'm going to create a boot CPU set. I want to create a login CPU set and then reboot. And then I want to get into running a program in the CPU set, and I need to go one step further and start pinning and turning off the CPU scheduler, and then check for the affinity. I'm going to do this through a PBS Pro type of interface as well as interactive. Now there is a wrapper to DMD place called OM place. Two things that you need to worry about if you're using DM place: KMP_affinity has to be disabled. Oops. And OMP_num_threads also has to be set in your workload. No plus sign in here, just OMP_num_threads. Now OM place will automatically set those for you. It's a wrapper to dplace. Also, when I'm in a CPU set situation, again, we have that memory spread page and memory spread slab. This is one advantage now when we're in a CPU set situation. If I start writing a terabyte of dirty data, it's going to be contained within my CPU set. I'm not going to be able to step in other people's portion of the cache. So let's just go off and share my desktop here. I'm going to do this on Floyd 3. So to begin with, CPU map. This is showing me what I've got for a system, in particular how many sockets or nodes I have. Every one of those sockets has their own memory attached to the socket. In my case, I have hyperthreads on. So I've got actually a total of 32 cores, 4 per socket, but 64 CPUs when I'm done. And here's the key thing now. My first blade, this is the one that I want to turn into a boot and a login CPU set. I want to isolate everything as much as possible. In prior classes, I've put them both on the same memory and split the socket and said, let's put the boot on 0 through 3, let's put the login in 4 through 7. But then they are sharing, oh, well, in this case, not. No, I was saying I'll put 0 through 3 as my boot and 32 through 35 as my login, which meant they shared the same socket. All it took was me to abuse the login CPU set, and the boot CPU set was impacted, and I could not even log in as root. But I don't want to create that big of a problem this time. I'd like to keep my boot CPU set protected from everything else. So I'm going to take that one socket for the boot and one socket for the login. Now, if I repartition the system, by the way, all these numbers change. If I add blades or something, they all change. You have to be very careful if you're replacing CPUs, got blades disabled, things of that sort. I'm going to begin with a man on boot CPU set. And the first thing we got to do is put into my elilo.conf an init that's going to call boot CPU set instead of init to make sure that everything that init fires up stays within the boot CPU set. Not everything will stay within the CPU set. There's still things that have to be spread around the blades. But in particular, anything that init spawns off from the init.d directory. I'm also going to have to create an itsy-bootcpuset.conf file. It's probably already in there from my last class, and in there I specify what I want to be in this boot CPU set. So let's do the CPU map. Actually, I still have the data here. So I want 0 through 3 and 32 through 35. And that's what I have here. And I've got mem0. By the way, there is a var run CPU node map that can map which node a particular CPU is on. There's also library interfaces to do that sort of thing. libnuma. Oops. The libnuma interface would also allow me to map things between. Okay, the other thing then, let me do the CPU map again. The second socket is going to be 4 through 7, 36 through 39. Now I have a ITSI init.d script I put into place. I need to remember my numbers again. 4 through 7, 36 through 39. So during the boot process, I'm going to create a cpuset_login.conf, give it those CPUs, basically that socket and its memory, create the CPU set, then figure out from PS which CPU set or what the PID is of SSHD, and then put that PID in the login CPU set I just created. I have to worry about order precedence here. And I'm going to do a check config. And do an ls dash, well, ls is good enough, on rc5.d. Let's see. And I make sure that SSHD is running before the nothing script. Here's nothing, it's running at 10, and SSHD is running at 8. Now let me check my ITSI elilo.conf. And I'm going to add in a, could actually add in a whole stanza here. 1, 2, 3, 4, 5. I'm going to call this label SP2 CPU set. And stick in a /sbin, oops, init equals. It's going to call an init once it's finished with this. If you're in the real-time market with React, there is a React script that runs instead of that thing. Run the elilo command to sync that into the boot EFI SUSE. Oh, I didn't like. Let me do another edit on ITSI. I did have one there out there already. Let me just get rid of that one from a prior class. Okay, try it again. And I like that one. Let me just double check. I do have the init boot CPU set there. I do have it declared as my default. One of the things, by the way, I do like to do have a backup directory in case I have problems here. Trying to fix an elilo.conf from the EFI editor is not very fun. Should have done that before I actually changed my original elilo.conf file. Okay. Before I reboot, I do want to check something. What do I got there? I do have a 53 gig slab. That may be a problem for me. I do have things running on this system as well. I've got a Find, I've got code 11s. There were things that I set up from last night to create a large slab. Now let's see what happens if I reboot the system. That large slab is going to have to be synchronized, depending upon what's in it. I don't really care about the metadata for ganglia. I just killed it off. Now's the part where that large slab might be an issue for us. Trying to unmount file systems. Got a sync command running and it's in a D state. I actually still have all that other work running too. All non-interruptible. It's not going to get killed very easily. How much dirty did we have? So I still do have a 53 gig slab there. But no dirty or write back. It's the slab that we're trying to deal with here. I'm not sure how long I want to wait on this. I don't really care about the data that's sitting there, but I don't want to have to deal with the file system recovery if I can avoid it. Not feeling any response right now from the system. something here. Perf top, iGrab, inode stuff. Good enough. Capital E to expand, so I do see XFSI nodes being part of the whole problem as we're doing the sync. There's my inodes. What are we down to now? 30 gig. Well, that's still showing 50 gig total there. What else was in there? Extended 3 inodes, directory entries. I'm going to give up on this. I don't really care about what the data is. Let me just do a power reset P3. You would not do this in a normal situation, but I don't care what's going on there, and I just want to save some time. We're going to see a file system repair when it reboots. Okay, going to do UV-con. First of all, let me do a config-v. Do UV-con on the base I/O blade there, R1I1B4. Watch this blade come up. So that power reset starts off with this BIOS banner. We can see the reset coming in from my power reset command. There's a BIOS command that's going to show you basically the BIOS function that you're in during the boot process. If you ever have CAD errors, catastrophic errors show up, you'd always want to go to the blade that had the CAD error and look at the BIOS output coming from the blade, UV-con to that particular blade. Also on your big system, I'd advise you to actually time this out to see probably about a 45-minute to an hour boot for your system. You don't want to be 45 minutes into the boot and then find out from BIOS that there's something wrong. Kind of nice to have sanity checkpoints. Notice it's also going to EFI shell right now. Let me get out of there. Go to my console. You should see the console come up here quickly. But to be able to time this whole thing out so that you know how long it takes to do discovery and stuff. So I've got a reference or a baseline to say, well, I've been an hour into the boot, and then you go to BIOS and see you're still in a directory entry retry or directory memory retry error or something. Same thing with the kernel boot when it's in its discovery area. I'm not going to drop the EFI. I had it set to default to come up on that CPU set boot parameter. Let me do a tab though, and there I can see I'm going to come up with S/11 SP2 underscore CPU set. I hit a tab key to see what my stanzas or sections are in my elilo.conf. The top one is my default. So let me go with that one. Now, when the kernel is done with its initialization, we should see the CPU set for BOS information about the CPU set being created before we get to the init.d scripts. So keep an eye out. There it is. I'll scroll by quickly. Now, there are some warning messages in here that are don't care, can't attach a PID to a CPU set. Those are worker threads. Don't worry about that. So that all looked normal. Oh, now we're in recovering journals. This was the part that we, service interruption, created the mess. Had a failure on /scratch. Notice I do get the CPU set login created, and I'm also turning off defrag. Okay, we're booted. Now let me log in. So this one's coming in from SSHD. I'm going to cat/proc $$ CPU set. I am in a login CPU set. Let me go to the other window I had here. Don't really care about that one. Root, SGI. This one should be in the root CPU set. Or boot, I mean. This should be in the boot CPU set. There we are. It's in the boot. I would like to echo $$ into /dev CPU set tasks. And now my interactive session is contained globally across the system. Also want to bring up a remote desktop here now. And this would be contained within the boot CPU set because that's where it was fired up from. The only thing I put into login CPU set was any child of SSHD. And the main reason I wanted to go into here was PMGsys. Now, keep in mind, now that I've partitioned the system, everybody has a little bit less to work with. So if I am abusive on the system, I'm going to beat up on myself rather than stepping into the rest of the system. Now let's just cat/proc/$$ CPU set. This should be in the boot as well. PMG sys. Let me do an npviz as well. Again, on your system, these may take a long time to generate the scene and do the discovery. You're better off saving the -v file that comes out of them. Save that output, and then you don't have to spend time generating that scene every time. You just feed it into npviz, pmchart, or pmgsys. So there's my system. I'm in a, let me just bring up top on the console. I've got to be careful, I don't want to use that one. Which one is which? That's the top that I want. Hang on. So that's in the login CPU set. So let me try doing, oh, what happened with my Scratch? Scratch file system looks like it was okay. I did see a failure on boot, but I was expecting problems on boot because of the way I reset. Can't see anything there. Probably need to go back further, but I'm not going to do that. Okay. So let me just do a DD. Oops. I can see here in npviz, let me zoom in on that a little bit more. If I place my cursor, look up here in the upper left of the window. When I place my cursor over the red, I can see that that is CPU 5. Same thing over here. I can see that I'm all system time on that thing. Let's bring up top on this window. There I can see the DD. I can see the flush. Let's grep dirty/proc/meminfo. I've already got 8 gig of dirty data. I'm going to do a node info here. And I can see that all my memory is being allocated on node 1. I need to warn you about something here. There is a file, cat/dev/cpuset/mem_hardwall. A 0 says that there is no hardwall and that I should be able to do I/O or allocate slab or page cache outside my CPU set, but in fact it is behaving like there's a 1, not a 0. My dirty data is being contained within that CPU set. Which to me is good. That prevents that person from stepping into my CPU set. Everyone gets a little giggle out of this, but a cache is like a public swimming pool. Anybody can do what they want in the water. I don't want them polluting my water with dirty data. Now what's going to happen here, when I run out of memory, I'm going to start swapping. Actually, in this case, since this isn't dirty, this isn't an on, we got nothing to swap. We're going to get in a real bad situation here. I think I want to bring up my PM chart on my workstation here. By the way, let's also perf record-G-C, what was that CPU number again? CPU 5. I think it's a big C. I can see a little bit of other system time, probably from perf and stuff like that. Again, this is not organized on a per CPU set basis. It's kind of hard to see what things are in here. This one's easier. I can place my cursor over it and see that that's CPU 5. I'm just going to go back to here. Oops. I rebooted, so my Numulink statistics are not active right now. Let me get out of there. Let's do a perf report. This is what we were seeing before break, too. Oops, no samples. K-flush D is kicking in. That means we're out of memory. Let's do that node info. Not sure why perf didn't get any samples on that CPU, but I'm going to ignore that for now. So there, we're down to 36 meg on this particular node. It's all dirty. And we do have a little bit of slab in there as well. And the slab's going to have to describe that dirty data. It's contained within, let's do a slab top dash S space C. It's contained within that CPU set. So there's the buffer head too. The node info. Showing me that I've got, well, we got there almost a gig in the slab for the buffer header chain to describe the 30 gig of dirty data that I have there. I have a newer version of node info that has Shemem in here, and nowadays I need to get a non-huge pages in here, which is not showing up here. Let's see what we got going on over here. Oh, I was going to do a link stat-uv-capital A. See what my link statistics are like right now. Not real high. I'm seeing 20 megabyte per second. The one that I needed to add here is the node info. I can't put everything on one plot, so I'm going to put free as one chart and used as another. And since I'm looking at dirty date in this experiment, let me do that one as well. There's dirty. Accidentally got a metric in there. Let me get rid of that with the X. Add the whole group. And with these statistics, I don't like to stack bar them. It's not as easy to read. So there is one particular node, the blue one here. I click here and I can see that node 1 is all used with 34 gig of memory used. And down here I can see that it's all dirty. So this one's in the global CPU set, the root CPU set. By the way, a K-swap D with the node number at the end of it, so I can see that node 1 here is in a memory pressure situation. Let me try running a memhog on that node. Oh, wait a second. I want to be in that CPU set. There it is, but let me actually log in a second time here. I want to leave that DD going. So when I'm logging in, I'm going to have problems here because all the memory is going to be taken. Oh, it came in pretty easy. Take a look at top. There's that DD running. Let me cat /proc $$/CPU set. So I am in the login CPU set. Now let me try a memhog, 30 gig, and see what happens over here. Why do I see node 0 going down? That's the login CPU set. Could be going on to node 1. Interesting. It's going off node. Let's find out a little bit more here. Memhog 1 gig. So 5 gig. I'm seeing it impact node 0, not node 1. Let me echo a 1 to make that an exclusive. Oh, I'm not root. Now, CPU sets put up fences so that I can't break out of the CPU set. But the exclusives say that nobody can come into the CPU set. But I'm surprised that I'm able to break out of the CPU set in the other case. We also echo 1 into CPU exclusive. Let's double check here. I am still in the login CPU set. Let's cat /dev/CPU set/login/CPUs 4 through 7, 36 to 39, and mems 1. I want to try something else here. Echo 1 into mem_hard. Well, first of all, let's see what it is. Cat mem_hardwall. That's a 0. Let's echo a 1. Okay. So cat /proc $$ CPU set. I'm in the login CPU set, into a memhog 20 gig, and it's still showing up in a different CPU set. Let me try something here now. PS-E, let's grep for memhog, and I want to do a dlook summary on -P 8774. Oops, no P option required. Well, it still doesn't like something. Did the program finish? Yeah, it's gone. I try it further now. So I can see that a lot of the pages are coming out on node 0 instead of node 1. Looks like it's stalled out right now. So we're in an IO8 state on that thing. It should be starting to swap. It's actually going on to another node, node 3. Let me take 3 out. No swapping going on. It flipped over to the other node instead of staying contained in my node. Huh. Now we can see it's growing on node 3 once it ran out of memory on node 0. Well, this one is in the global, but I'm not running memhog in that particular CPU set. We can catch it with node info. So there's something wrong here. Node info is giving me correct node information. When I'm looking over here, I'm seeing something different. It is going off. Okay, it is. The anon is going off to node 0 and node 3. Looks like it just finished. But I'm not seeing this being contained properly right now. I do have a command called cpuset-Q. Let me just take a look at that report. So I got my global CPU set, the exclusives are up, mem hardwall is 0, spreads are at a 1. Memory pressure says keep track of which socket is actually, or which CPU set is swapping and running out of memory. And my K-swap D-demons, I do see K-swap 1 dealing with a memory shortage on that particular node. None of the others yet. I still have the flush daemon dealing with stuff. And here's my login CPU set. I want to try something here. And also let me do an echo of 1 into memory underscore pressure. Oh, memory pressure enable, where is it? Need to go up a directory. Echo 1 into memory. And that'll give me statistics on which CPU set is actually getting into a swap situation. Let me go back to where I was. Trying to contain this within a CPU set. /proc/$$ CPU set. Now, one of the differences here was with node info, that CPU set is full of dirty. For out of memory on that CPU set, all of it being from this dirty. But memhog 60 gig. Again, I'm only seeing CPU 0 or node 0 get used. I'm checking affinity for this thing. ps-e grep for memhog. Okay, cd into /proc/8956 and cat the status file. And in here, mem allowed list is only 1. It's only supposed to be able to get to node 1. See, that is CPU 5. That's node 1. Let me add one more set of charts here. Anon pages. Wonder if it's because of anon huge pages that might be doing it too, but do anon pages. And anon huge pages. I need both nowadays. Oh, looks like on a per node basis, I'm not seeing anything that is a non-huge pages on a per node basis. Doesn't look like they have that statistic available there yet. Here I can see where I've run out of memory on 2 nodes now. See a non-huge pages on that particular node. We're on 0, and also the green one, which is node 3. Process is finished now. Still have a lot of dirty data. Let me try this now. Kill all DD. And let's try a sync. I want to see that dirty memory get flushed. Did I have dirty here? Let's see, use dirty. Yeah, I have dirty here. Kind of see the red going down a little bit. Now, there's something else I'm going to try here. I want to start PBS and submit some work through PBS here. I'm not seeing the CPU sets working the way I would expect. So maybe there's something in my man line, C groups or something like that. C group disable. I wonder if that might be doing it. I'll try something for the next boot. There is overlap between C groups. That's the only reason I'm wondering if that might do it. Just looking to see what else is in there. Okay. Elilo. Next time I boot, I should have that off, and I may have to do that. Okay. ls-dev CPU set. So I have the boot and the login. Now let me do a service PBS start, and it's going to find what CPUs and nodes are not assigned to any CPU set and invoke them. Let's go into dev CPU set. There's now a PBS Pro CPU set in there. Go into that one. And let's cat the CPUs. 8 through 31 and 40 through 63 are the sockets that are left over. Eight through 31, 40 through 63. So only the first blade, the first two sockets, are part of the boot and the login CPU set. Now, when I submit to PBS, it's going to, by default, give me one socket. Let's check the MEMS, and that was 2 through 7. 0 was for the boot, 1 was for the login. Let me just do one here. Let's do a more. I wanted to do a memhog one. Wondering if I have a good example here. Let me copy 70-mem and do 70-memhog.pbs. So by default, I'm not specifying anything, and this will show up as a single socket. And let's see what happens to this. So that memhog is in there. Again, I've got a script here. Let me put it into a file. There's my boot CPU set and all the threads that are in it. Oops. Then my PBS Pro CPU set, which we've already looked at, and underneath it is the job that I'm running. Doggone it. Back up here. And that one is, mem hardwall is still 0 there. Spreads are 1. Then there's my mem hog. Now where did it get assigned to? Assigned to node 4. Is that where I'm getting my memory? I'm not seeing it on node 4. So it looks like it's being spread across node 4, 5, 6. What I got here? Now PS-E, let's grep for memhog. That thing has a affinity mask to it. Oh, 9489. So it's in that CPU set. And status showing that mem allowed is only 4. Let's see where its pages actually are. 9489. And it's got its pages spread all over the place between node 4 and 7. So there's definitely something going wrong here, in my opinion. Double check I got rid of that. I want to reboot the system and try this again. Get rid of the dirty and see if things can be contained. I can only think that C group disabled, C group memory disabled might be part of my problem. I am seeing CPU affinity, but I'm not seeing memory affinity, despite the fact that the status field is showing me that I should have affinity. Again, if I look at this process, I don't have it there anymore. So let's reboot. I don't care about the data that's there. I want to save time right now. Power reset P3. I'm going to continue this even if these CPU sets aren't quite working the way I expect, and try running some different jobs in different CPU sets. Pull them apart, and then wrap up for the week. I don't plan on going more than an hour right now. We've been going about an hour on this particular session here. But that process within that CPU set, we saw the status file showing an affinity to the particular node that was given to it by PBS. It was in that CPU set, but it was allocating outside that CPU set. We could see that from the node info. We could see it from PM chart. We could see it from a DLOOK, and then I've got that DLOOK summary. These are two scripts that I advise you to grab from me, DLOOK summary and CPU set -Q. They're extremely useful, particularly in a large CPU system like you've got. By the way, while that's happening, we can do a watch BIOS-S. Waiting for the serial console still. Should be real close now. There it is. Not going to drop the EFI. But what I was trying to show here, we did see the dirty being contained within the CPU set. I want to show shamem and clean being contained within the CPU set, but the processes themselves for the memory mapping and malloc and memory and stuff were breaking outside of the CPU set. That should not have been happening. And it had an affinity mask as well that said stay on a particular node, but it was still going off node. It should be going to swap, fill up swap, and then hit an That's what I wanted to see, was this memhog stay in the CPU set, fill up swap, and then hit Let's see if there's anything relevant in there. I'm just checking to see that the memory, C group memory disabled was not in there. I don't see anything in there right now. Now there's a UV config command that's going to make sure and add it back in on boot. There's orphans because I did a hard reset on the file system. So there's where it actually caught that change. It probably put that C group back in. There's an itsys config UV config file that would have to get tweaked. So more on itsy lilo. Oops. And looking to, well, I kind of made a mess here. I've got a slash in there too. And here's where it added C group memory back in. I've got to be careful of that. I don't know if that's related yet anyway. Let me cat/proc $$/CPU set. So I'm in the boot CPU set. Okay, let's try this again. /proc/$$ CPU set. So this one's in the login CPU set. Let me just start off and do a memhog here. And see what node is allocating on. And it is staying on node 1. You see a little bit of a none on node 0, but I'm not seeing that change. Now, is it going to go off node? You do first touch. The question now is what's going to happen when I run out of memory there? Am I going to go to swap? Oops, must have finished. Try it again. I needed to, again, first touch, we allocate on the node we're running on at first, but then the question was, will it break outside of that node, or will it swap? Let's bring up my PM chart too. Watch for swap traffic. Oh, that one's working correctly now. We are swapping instead of going outside that CPU set. And we can see that here. We're down out of memory, and there's what's going on the first node, though. We do have some allocations going on the first node. So ps-e, let's grep for memhog. Oops, must have finished by now. Let's try it to 80 gig. Was cat/proc $, no, 7923 CPU set. That's in the login CPU set. Let's cat its status file. That says it can only go to node 1 for memory, and same thing for the CPU sockets. So now what's dlook summary going to give for me? 97923. Must have finished again. Oh. Seven, 9, 2, 3. Oh, right. And we can see all the pages are showing up on node 1. One of the things I do is I can grep for an all. There I can see it does have some pages on node 0, node 3. It is breaking out of the CPU set. Can we see that with PCP as well? Yes, we can. So still not saying contained here. Why? I was swapping before. Why am I not getting to a swap situation again? Oops, let's put that in quotes. So it is able to break out of the CPU set. Now, why was I swapping before instead of this? Am I in the proper CPU set? That is in the login CPU set. But it's definitely breaking outside and now going to node 3. And just to confirm, when I take a look at the status file for it, so that should be just on node 1. Okay, so we've seen the slab and the dirty stay within the CPU set, but not the user memory stay within the CPU set. We've seen dirty, slab. I should try to do a read. Go back and see what's going on here. So it looks like it's on node 3 right now, and pretty soon we're going to be rolling over to another node. And we can see it roll to the next node. Now, by the way, this is for allocations, but this is saying that I allocated on node, which is good. But then this is saying I had to go off node, so we're getting off node references, and then that comes in on another node as a miss. And this is going to tie up the interconnect. Let's see what the interconnect activity looks like. Oh, I don't have it turned on after the last reboot. Right. There's my interconnect traffic. And we're close to a gig going off on this node. Blade 4, port 3, way up there. Why before did I see a little bit of swap action going on, but not what I expect. It should have just all stayed into that CPU set and gone to swap and died. I can't think of anything that I've done wrong. Everything looks okay. I've stopped that allocation now. Let's see what my interconnect looks like. I do see all the swap space gone. All my nodes have cleaned up. And my Numalink traffic is stopped. Oops. Actually see two of these mem hogs running now, and just kill one of them. It's asking for 200 gig. I'm also going to submit two other jobs here. Let me submit an MPI job. Go with that one. And I also want to submit a couple other things here. Oops. Oh, everything but one is running. Oh. I just see my anon pages being spread across these upper sockets. You'll see a large slab on two of them as well. This is where my CPU set dash capital Q with the dash V for verbosity comes in handy. Going to go through every CPU set, do a PS on the processes in it, grab the status file to get the affinity information, run a DLOOK summary to find out what nodes the process is on. So then I can correlate what CPU I'm running on, what memory I'm getting, and look for affinity. Oh, that yellow. So this is non-pages and the non-huge pages. At least I am seeing a little bit more swap activity this time, but I'm still not convinced of that. That it's still busting out of the CPU set. This report will tell me when I'm done. Jobs are just about finished here. I'm going to pick one of these job outputs. Oh, it didn't find I for it. Let me find. But we do still have those memhogs running. Let's just see what we got here. /proc/8838 CPU set. So it's in the 703 CPU set. Let me cap the status file. It's allowed on CPU 5, or I should say memory node 5 there. But where is its memory? 8838. And it's all over the place. It is definitely going outside the CPU set. And we can see kswapd is handling it as well. What happened to my other job here? Oh, path problem here. Okay. Source/SW Intel bin port bars .sh. Instead of fixing the module command, I'm going to just source this thing. Still not right. Oh, I missed the switch here. Needs to know what kind of architecture it has. There's the compiler coming in. So I'm trying to look at affinity information, but the CPU set fence is not working. It's allowing me to allocate outside my CPU set off my nodes that are not within the CPU set. Okay, it looks like something is running now. Oh, might have just finished. Okay. Do something else here now, real bad. More threads and I've got CPUs. Let me bring up my remote desktop here. I'm having trouble getting any response out of this because I'm coming into a CPU set that's got all that memory pressure on it. So I can see some system time and some I/O8 down in here. Looks like my job finished already. Oh, resource temporarily unavailable. Would not allow me to get that big. Try 64. And since I haven't declared any CPU counts or anything, I should be getting just one socket. There's my code 2MPD place running. Now this is a multi-threaded application. I'm going to do a capital H. Oh, threads were on before. Let me try something now. Do stat-A. Job is still running. I'm going to do a CPU set dash capital Q dash V, and then try a 714 and see if that does anything for me. It does. Let me dump that into a file. So what I'm doing now is running on the CPU set itself. Well, maybe it's finished now. Yeah, it's finished. I kind of missed it. Let me do it again. Let me just give an example of one. CPU set dash capital Q. Again, this is a script I wrote. I'm going to pass in the job ID 703 in this example. Put it into a file. If I take a look at that report now, I see the name of the CPU set. DBS automatically created one. It grabbed a socket. It grabbed node 5, 8 CPUs on that socket. Then I'm doing a PS on everything that's in that CPU set. So here's a PS line. Here's the task set. Here's the affinity mask that I have. And then here again shows me the CPU memories that I can use and the CPUs that I can use. And then it's actually running the DLOOK summary. And I can see this thing has most of its pages on node 0, which is where the bash shell would be in the first place. Then we've got memhog here. This is the one that should only be on CPU 5, or memory socket 5. But in fact, we can see it's got pages spread all over the place. So these are pieces of scripts that I've written myself to make it easier to pull apart a situation like this. Okay, I do have one running here. Let's see if I can catch it. CPU set dash capital Q dash V on 716. Do more on RPT, and there's nothing in it. I missed it. It's all gone now. Let me try that again. for the compilers to get past things. Got one running. Okay, CPU set dash capital Q. I'm just going to do them all. Just going through each CPU set, giving the attributes of the CPU set, and then for every processor thread in the CPU set, giving me information about that. Let's take a look at this report. There's my root CPU set. And here's the PBS CPU set, and underneath that, there's my job 720, and it has code 2 MP dplace running. And I see each of the individual threads. I didn't get a -V option on it for some reason. Let's see what's going on and try that again. Looks like they're all running. Let me try it again. CPU set dash capital Q dash V into RPT. The V will give me the affinity information. See what's going on back here. I have a lot of threads spawned off. See where my load level is, slowly growing. It's running a PS and a task set on HPID, slowly advancing. Now what you want to do is be able to see privatized. In fact, let me go back to here. Let's get out of here, go into top. I want to sort by the CPU number. My work done? Everything's finished now. Break out of here. More on RPT. Here's the global. Actually, let me go for code 2. Doesn't look like I even caught it here. Looks like I missed it all. Try this again. A little bit easier when the jobs are sticking around for a long time. Now notice I've got several threads on the same CPU. If I go to capital O and sort by the CPU number, which is J, I can see I've got a whole bunch of threads on the same CPU. Now this has come back. Let's take a look at that. So here I'm looking at just the CPU set for that job. You could easily modify this for your MOAB conventions. There's my shell on node 0. Then here's all my individual threads. I deliberately created extra threads so they stick around longer. And for each thread, let me back up here first. I'm on node 5 with 8 CPUs. And I can see all my pages are also on node 5, and the MEMS allowed are on node 5. But also notice how the CPU allowed list is skewing. So I'm going 21, 22, 21, 21. I'm not skewing very well. Most of these are staying on CPU 21, which makes me wonder if I have KMP affinity set correctly here. They're all on CPU 21. Let's do a VI on 28 again. I do not have KMP infinity turned on. Export KMP underscore affinity equals disabled. Here's my OMP num threads. I was going 64 threads wide on an 8 CPU system, or 8 CPU set. Let me okay. There they're running. I am still able to see multiple CPUs here. Oops, they're all on 23. But part of that, again, is because I've got more threads than CPUs. Let me see what that report gives me. So, got node number 5, 8 CPUs. Don't care about the bash shell. There's all my threads spawned. CPUs allowed 22, 23, 22, 23. I wonder what grep CPUs under, oops. I'm still only getting 21, 22, 23. Oh, the reason for that, let me VI on 28. My D place was only going for 4 threads. Since I've got 8 threads, let me go 0 to 7. Let me make this 16 threads wide, which is still bad, but again, I'm just trying to keep this thing from sticking around long enough. I'm going to do one last thing here. Let's take a look at this. So I got node 6 this time, less threads, and then CPUs allowed. Notice the memory is staying on node 6 here. That's all going to be because of first touch. This thing isn't big enough to go off node. And CPUs allowed are skewing. So now let me grep CPUs allowed. Oops. And I can see 24, 25, 26, 27, and then wrapping to the virtual CPUs 56 through 59. And then I had my MP3, I had my num threads, OMP underscore num threads greater than the number of CPUs that I was given by PBS by default. And it wrapped around. Let me do another one here. We'll go 16 threads wide, do something like this. Okay. Let's take a look at that report. Actually, just grep again. So 24, 5, 6, 7, 8, 29, 30, 31, then wrapping 31 through 24, coming back around. I still got a problem in my wrap here. Let me VI 28 again. I'm going to go to that D place and go 15, 0 through 15 this time. You sub that again. Wait for it to get started here. Okay. I'm still expecting a problem here. Notice I've got two things on 16 here. Okay, let's take a look at that one, RPT1. So this one is on, I got two nodes this time because I asked for extra CPUs. 16 CPUs and 2 sockets. And I can see my memory affinity is into the 2 sockets here. And then for each of the threads, also affinity with the 2 sockets. Now, scroll up here for a minute. So looking at this, these are going to get placed by D place, 16, 17, 18, 19, 20, 21, 22, 23. Then to the virtuals, 48 through 55. And then back to 16. So I still have 2 threads on the same CPU. This is something you got to be aware of with Intel OpenMP. The second thread is a shepherd and does no work. We do not want to pin that. I asked for 16 CPUs, but I actually got 17 threads because of that sleeper in there. So I need to ignore that. Let me do this again, 28 dash asterisk. And I need a dash X2, which is going to skip that second thread and say don't pin it. I'm just curious here, where were we here, doing more just wondering where my time was. I'm not really doing a D place. Let's see, 39 seconds. I just want to see where we've been. CSA com-n code 2MP DPLC. So all these different runs, I'm down to 39 seconds right now. But worst case, I was up in the 100, 200 second range. So I'm at 39 seconds, but again, the second shepherd that gets spawned off doesn't do any work, and we need to not pin it. Now let's try this again. Okay, it's running. Let's get the report. Oops, wasn't quick enough. It's getting too quick now for me. Let me try that again. There they are. Okay, let's take a look at this report. So I'm on nodes 6 and 7 this time, 16 CPUs. Again, I do have shared text that's still going to be in node 0, but I'm basically split between 6 and 7 here. 6 and 7 again. Then I've got all my processes, and note this time now, I did not pin that. It went 24, skipped this one, and then 25 on down. And then we did not wrap. We ended up nice on 63. And then if you look at this affinity with CPUs allowed, this one is on 24, but the shepherd that's not doing any work is sitting there with no affinity to it. And then we're going 25, 26. Let's try grepping that. Where was I? There we are. So we had the shells, and then our worker, and then we skipped, and everything was nice and clean here. Let's see what we got for CPU time. We're down to 12 seconds. Just that one change moved us from 39 seconds to 12 seconds, it looks like. Try that again. Fire off a couple of them. Again, this one is still not completely tuned because I'm still doing off-node references. The way this OpenMP zeroes out, initializes, and allocates the array is different than the way it processes the data later. If I take a look at this report that we were in and look at each of these threads, notice they're evenly spread between 6 and 7. Let me grep for all in the report. And you can see 6 and 7, they're evenly spread between them, and that's not the way you want it. Let's see what we got for timings on that one now. CSACOM-N code 2MP. 12 seconds. So I was in the 39, 40-second, even 200-second range. And now I'm down in the 12-second range. Now that's still not necessarily productive here. Let me VI that 28. And I want to try doing a PS run. Oh, well, that's going on. I want to do something else here now. Getting ready to wrap up here for the class. I'm going to put myself into the root CPU set. So I'm in the global and have no restrictions now. I'm going to go into home. I've got a single-threaded version of that program that we were just running, code 203. Let's just time it here. Oops. It doesn't look like I have it. Let me source. Actually, let me just do a G4tran. Uh-oh. Maybe it was there and I just don't have it. Compile it. So let me do a time on code 203. Oops. Actually, I should have compiled it with optimization on, but let's let this run. So what I want to do is use NUMA tools and the NUMA CTL command to put them on just single threaded, put it on the same socket, and then put it on a different socket. Only allocate memory from a given set of nodes, only execute a command on a set of nodes, or I can bind to a particular CPU. While that's running, let me go back. I'm going to do a module load, I4, Intel-12.1 was my module. Let me do an I4-03. This one finished yet? Still not finished. Okay, let's try running this one. Looks like that just finished. That came in at 1 minute 39 seconds. Let me compile that again with a -03 using the GNU compiler. And let's do one with the Fortran compiler here. The new Intel compiler is coming in at 9 seconds. 21 seconds for the GNU compiler. That's the difference the compiler will make in this run. Let me run a couple of these just for confidence interval. Again, there is noise coming in on the system. Okay, so they're all coming in 9 seconds. Now let me do a NUMA CTL. So I want to do an M to specify to bind particular node and big N for the node that I want the CPUs on. I've got 7 nodes on this system. So let me do a NUMA CTL dash big M. Wasn't that it? I forgot the syntax already. Little m, big N. Little n, let's put it on 0, big M. No, little m, big N. And I don't really have a timing coming out of here. Oops. Node argument is out of range. I probably should put this under a time command, but it's CSA COM-N and code 2 Intel. Oops. Those are all coming in at 9 seconds. Let me do another one for confidence interval here. Then I'm going to try it to a different node. That's still coming in at 9 seconds. Now let's try it to a different node. it doesn't like my syntax here. Am I in a CPU set? Oh, I am in the login CPU set. That's the reason that syntax is giving me a problem. Let me get out of that. Actually, let me put it under the time command too. Still in the 9-second range. Let me run it again. Now let me try going to a different node. What's it doing to me here still? Shows me I have 7 nodes. Oh, I'm still in the login. Echo $$ into /dev/CPU set/tasks. Now let's try that again. So I'm using node 1, but placing my CPU work on node 7. And we went up to 11 seconds. And this is just a small 4-blade situation, not something like a 256 socket system. So those are all coming out from 9 seconds to 11 seconds. That's almost a 20% degradation. I won't go that far. See if I go to 0. Go back to 1. Oh. 9.42. That's just going to the other socket on the same blade. Put them on the same again. We should be back to the 9.0. And there we are. That's fairly repeatable and predictable. At this point, I think I'm done.